Hey friends, it's John. You're on the JRB Tree Climbing channel. Here in my hand, formed with a single piece of cord, I have 3 secure loop knots. On the left is the figure 8 end loop, or figure 8 on a bite. See my dedicated video on the figure 8. In the center, we have the alpine butterfly, and as it's tied here, it has the advantage of being able to be tied in the bite in the center of a rope. And on the right, I have the Scott's Locked Bowline. I discovered Scott's Locked Bowline while researching secure bowlines quite a number of years ago, and I discovered discussions on it on the International Guild of Knot Tiers forums. I believe it was devised in approximately 2004-2005, and the inventor's name, logically, was Scott. And Scott, we want to thank you for this creation, as it is quite useful. And if you see this video, I'll be showing my audience, climbers, a unique application for it. And while I have it in my hand, let's start with some of its unique properties. Notice that as I have it here in my left hand, there's some space between the strands, the end of the strands forming the loop as they enter the binding portion of the knot. There's some separation, there's some space here. When I compare that to the other 2 loop knots, they have at a very acute angle. And so if we're trying to pass something through this, like we do in certain rigging scenarios, this acute angle can be a problem, where Scott's doesn't have that. And another property of the Scott's Locked Bowline is when I orient it vertically and put tension on the tail and the standing end, it orients itself in a fairly horizontal fashion. And I flip it the other way, orients itself in a fairly horizontal fashion with the loop. And if we fashion it with a stiffer rope, as I have here, so this is a 9.5 millimeter rope I use for climbing. It's the ghillie rope that we're all liking so much. It's kind of stiff though. It's a little harder to tie knots with it. But that stiffness can be leveraged in certain rigging scenarios. So if I was bringing this up into a tree and it's hanging down, and I had affixed here onto the tail one of my JRB end loops, and I applied tension, watch what happens to the loop. It orients itself in a horizontal fashion. Well, okay, what if I pull the other way? Same deal. It orients itself in a horizontal fashion, and it's got a fairly oval shape. In fact, I can flatten that out before I climb, and I can leverage that shape and that position in certain climbing applications. And that's why I am showing you this knot today. Okay, let's get started and learn how to tie it. So if you're familiar with the standard bowline, you've got a huge head start, because the Scott's Locked Bowline is effectively a standard bowline with a secure finish. So I'm right-handed. I'll be tying this in the right-handed chirality. The working end is hanging down. The standing end is here in my left hand. We'll zoom in just a little bit. Okay, I will start by forming an overhand loop in the Z chirality as such. And this, I believe, constitutes what we call our nipping turn, or our nipping bite. And the way I learned this, and so many before me, there's a saying which is that the rabbit comes up out of the hole, goes around the tree being the standing end, and goes back down the hole. And this is going to form a standard bowline, but with an obnoxiously long tail. Note that in the standard bowline, the tail is in the center, not the outside. If I had formed this the wrong way, this would have been on the outside. We call that a cowboy bowline, and we're not interested in that. This is the standard bowline. And now, the finish for this will be to take the working end and to insert it back up in this location. I'm going to take my handy dandy nail and insert it exactly the path that it will traverse. Okay, here we go. In and out. Draw the slack out. Now I didn't dress it out yet. I want to stop and show you how the working end and the standing end, now the tail is the working end, they exit side by side. And I started on the left, it exits on the right. I will draw it tight by pulling on all 4 strands, tail, standing end, both sides of the loop equally. And then let's take a closer look at that. I'm sorry, but I tend to always see faces in my knots, and I see a nose, and I see 2 eyes, and I see 2 cheeks. Maybe that's just me, but I always see faces. And I generally do my inspection from that side. I don't generally turn it over, but that is the back side. Okay, let's take it apart. Now, even with significant load, by breaking this collar here, breaking that, it's generally fairly easy to untie. But the kind of loads we're going to put on it, just our body weight and the canopy, it's never a problem to untie. And we'll want to periodically inspect our, especially when we tie with stiff ropes, we'll want to inspect them. I haven't loaded this one yet, and make sure that it's indeed always cinched tight. Okay, let's tie it again. I start with my overhand turn, and as the working end goes down to the ground, note that it is over, it is not under, it's over. And back to my rabbit analogy, rabbit comes up from the hole, goes around the tree, goes back down the hole. At this juncture, I generally will size my loop if I need to sneak in any extra slack from the working end or take any out of the standing, and I will do so. I need to have a fairly long tail when I finish this. I'm going to go right into that location and exit adjacent the standing end. I didn't overdress that yet. Let's just keep it in our field of view and inspect it. Again, I started from the left and I exit on the right. And there's that face, there's the nose and the 2 eyes. Okay, now I want to try to do this one more time in the S chirality. Let's try this. So I've got the working end here, and I will form that overhand turn. The rabbit comes up, goes around the tree, goes back down the hole. Obviously, I formed this one a little smaller. Let's go with it. And then I lock it by inserting the working end there and out by the standing end. The tail length, I've read different things. I read that in rock climbing they like a really long tail. I've always just gone by the rule of thumb that the tail on any knot should be at least 10 times the diameter or several inches, right? So if the diameter were 7 millimeters as it is with this cord, we'd want a tail that's at least 70 millimeters, and by my eye that meets the criteria. But I've loaded these really good, and I haven't seen the tails getting sucked in. And so there you have it, Scott's Locked Bowline. I can't wait to show you how this is used in canopy anchor rigging scenarios.